Hello everybody, my name is David Zarruk. I am the head of data science for RappiBank in Rappi in Latin America. And the title of this talk is called Experimentation as the Backbone for Decision Making. Let me describe briefly what Rappi is. Rappi is a marketplace in which customers, stores, merchants, and couriers find themselves to exchange goods and sell goods. Inside Rappi, we have multiple lines of business. We have grocery deliveries, pharmacy deliveries, restaurant deliveries. We have a fintech arm in which we offer a credit card to users, among many other services. Rappi has established over the past 6 years a massive user base throughout Latin America. Right now, in particular, we are in 9 countries in Latin America and in more than 100 cities throughout the region. We have more than 11 million active customers every single month. And during our first 6 years, we had growth rates of more than 20% month over month. Last year, we had 750,000 couriers connecting to the app. And right now, we have more than 80,000 merchants also connected to the app. Rappi is a company of more than 3,000 direct employees in the 9 countries in Latin America. Of course, as a data company, we are basically taking every single decision based on data. Data is our secret weapon. And there is a very broad range of problems which we tackle with precisely data. Here are some of the main challenges that we face throughout the different verticals or sections of the app. For example, we have to define customer segmentations to be able to offer different products to different segments of customers. We have to do well in estimating the ETAs of every single delivery. We have demand and supply optimization problems and forecasting problems. We have also search engines, we have restaurant recommendations, we have credit scoring models, we have growth marketing, and we have fraud detection models, among many others. And the way in which we iterate on each of these single problems is through experimentation. So how do we measure impact every time we try to measure a new feature or a new algorithm? Basically, this is done through an experiment or an A/B test. What we do is basically we split the population between 2 groups, the control group or group A and the treatment group or group B. What we do then is to group A, to the control group, we show the old feature or the old algorithm. And to the new group, the treatment group, we show the new feature or the new algorithm. We let the experiment run for as long as necessary to achieve the statistical power required for the experiment. And then in the end, what we do is we compare the results and the outcomes according to some certain metrics of success between the control group and the treatment group. The final decision is then to choose between the new feature or the new algorithm and the old feature or algorithm according to which one has the largest, for example, conversion rates. And this depends on whether the new feature performed better for the aggregate set of users or for particular segments. It might happen, for example, that a new algorithm performs very well in certain cities but not in others. In that case, the decision is we should adopt or take the new algorithm for those cities, but in the cities where this new algorithm didn't perform well, we should stick to the old algorithm. All of this is experimentation. So why is experimentation important? Experimentation is important because it's the best way to measure the impact of the new feature. If we don't measure what the impact of a new feature is, we will simply be iterating over our features or our products blindly without knowing if we are actually improving upon the old features. Many times, as data scientists, we used to base our decisions on offline metrics. It makes sense, for example, when we are working with recommender systems to look at the map at K, or when we are constructing a classification algorithm to look at the precision or recall of these algorithms. However, it turns out that many times when we put the model into production, these online metrics and the offline metrics do not necessarily talk with each other. And the offline metrics are not the best way to measure the impact. The gold standard of impact evaluation is experimentation. In a data-driven company, such as Rappi, experimentation is extremely easy to implement and it's very low cost. The potential losses of making blind decisions are huge, or equivalently, the potential gains of making correct decisions based on experimentation are huge. Therefore, there is no reason not to experiment in a data-driven company. So let me go back to one specific example in which we perform a lot of experimentation inside Rappi. And this is the case for restaurant recommendations. When users enter the app, when users enter Rappi, we want to show them what is most relevant for them. So if you are a pizza lover, we would like to show you pizza restaurants. But if you are in the office and you like to eat salad during office days, we want to show you salad. The thing is, this problem is not a trivial one because there are many factors kicking in at the time of choosing a restaurant. For example, we have to define what does restaurant similarity mean. How do I define if a restaurant is close to my tastes or not? We have also to take into account factors such as distance constraints or time constraints. For example, during the weekdays, when I am in the office, I rather eat healthy or a salad, whereas when I am on a Friday night watching a movie, I prefer eating pizza. So time and the location where you are definitely define what you would like to eat. There's also this trade-off between exploration and exploitation. There's a lot of customers that love to explore new restaurants. There are other customers, in contrast, that do not like to explore and they would rather eat in the same restaurants in which they have eaten in the past. So this is not a trivial problem. Basically, what we do when we construct algorithms to recommend restaurants is we take every single user and we look at the past orders of these users. What we do then is we take these past orders and map them or convert them into a vector that describes the tastes of the user. We do exactly the analog for every single product and every single restaurant that is registered to Rappi. So then what we do is we have our users, we look at the similarity between every user and every single restaurant in the app, and then we sort the restaurants according to what we believe is your best, what we believe is the best way of ordering restaurants for you. So basically, when we have two algorithms, algorithm A and algorithm B, which show different content to the users, the best way to decide which of them is better or which maximizes, for example, user experience and the business metrics is through experimentation. How does Split support our experimentation practice? It turns out that experimentation is really easy through Split. Basically, the largest cost we have to incur in when we want to do an experiment through Split is the cost of integrating that particular feature we want to experiment with Split. So let's say I want to start experimenting with the picture size in the app. Then I would have to go and schedule with the backend team so that we develop this integration between Split and that particular feature related to the picture size. Once that feature is developed, turning on an experiment is pretty straightforward. Basically, what you have to do is you create your Split, you select the number of groups or treatment groups that you want to experiment with under configurations. You select whether you want to whitelist or not certain particular users. Then you choose the traffic you want to send through each of these treatments, where you can do stratification or targeting rules to send certain users to certain particular treatments, and then you can turn on your experiment. And that's it. It's really easy. Finally, I would like to talk about how to create a culture of experimentation inside your company. Basically, what I've seen is that the culture of experimentation has to come from the leadership of the organizations. And if the leadership does not have a strong statistical background, it's not that easy to implement a culture of experimentation. And this is basically because usually counterfactuals are not observable. What does this mean? This means that If you're a company that does not experiment every time you roll out a new feature, you are simply not going to be measuring the impact of that new feature. You might be going through the wrong path every time you develop a new feature, and you will never notice you are actually going through the wrong path. In particular, there are some other obstacles that make experimentation difficult to implement as a culture inside the company. The first one is that experimentation usually can slow down the development of the product. Let's assume you are a product manager and every single week you develop a new version of a certain feature. If you don't experiment, you'll probably every week put into production that new development of that feature. So when you look at the app, you will see an app that is evolving week after week. When you start measuring the impact, in many of those new developments, you might notice that you are actually not improving upon the past version of that feature. You might actually be reducing the metrics you are interested in maximizing. In that case, many of the iterations of that feature will never see the light or will never be rolled out to users. So it might feel like you are not moving as fast as you would be without experimentation. This, in some companies that are very fast paced, can seem to go against the culture of the company. However, experimentation, what actually does is ensuring that you are moving in the correct direction. You might be moving slower, or you might think you are moving slower, but you are doing it in the correct direction. Second, experimentation requires team members with a strong statistical formation, which is not common in every single team. So you have to invest time and effort in recruiting people with statistical skills. And finally, experimentation is very good or suitable for companies that are already mature enough that are iterating over already existing features. If you are a company that are still creating version 1 of every single model, then you are still not iterating over those models, and there's no reason to experiment. But once you start trying new and new models every time, or new features, it's a good idea to start experimenting. Thank you so much, and I hope this talk was helpful for you.